Hello friends, this is Bright here. Today we are going to see how we can implement Caesar cipher in Python programming. So let us see what is Caesar cipher. It is one of the earliest and a simple method of encryption technique. Here, each and every letter will be replaced by another letter. For example, you may look at this original text here. So here I listed from A to Z, and we'll say that some integer will be added with every letter. Let us say we are going to add 4. Then A plus 4. It means plus 1 means B, plus 2 C, plus 3 D, plus 4 E. Next, when we add B with 4, we should get F. So every letter is shifted by a number of letters. That is called Caesar cipher. Now we should know when we add A with 4, how we can bring E. For that, we are going to discuss two functions. One is called ORD, where ORD of any letter, it gives the Unicode. For example, let us say that result equal ORD of A. Here it gives the Unicode of A, that is 97. So I am going to print it. So when I run it, you can see that here it gives 97. With that Unicode, we can add any integer value, let us say 4 or 5. So here we are getting 97. Let us say that I am going to add plus 4. Now it gives 101. But when you add A with 4, we should get E. So from 101, how we can bring E? For that, we have a function called CHR. CHR of 101, and it can be stored in some variable CH. And now let us print CH. And now you can see that when you are adding A plus 4, we are getting 101. And when we are converting to character by using CHR function, we will get its equivalent character, that is E. In this implementation, we will be using these two predefined functions, ORD and CHR. Now let us start writing the code. The first step is read message from the user. So this message only we are going to convert, or we are going to encode into Caesar cipher. For that, I am going to use a variable called myMessage. To read any data, we can use the function input. Now here we have to add some data. For that, I am going to read the distance. The distance, it can be 4, 5 or any numerical value. For that, I am going to use a variable called distance and read it during runtime. And since we have to add this distance with each and every letter, I am going to convert this distance into integer. After adding distance with every letter, we have to show the encoded data, that is ciphertext. For that, I am going to use a variable called ciphertext. So it is an empty str. So before going to continue, let us have a look over this diagram. You can see that here it is listed from A, B, C up to Z. And we know that the small letter A, its Unicode is 97. For B, it is 98, 99, 100, and it ends with 122. Let us say that we want to add A with 27. Let us see how it will be processed. A with 25 means we will get Z because we know there are 26 letters. But we have to add with 27. So plus 2 more. For that, 2 more means now we need to loop back to here. So it becomes 26, then 27. So what may be the outcome? A plus 1, isn't it? Next to A, which gives B. So once again, A plus 27 means you can sample it, that is 25 means Z, loop back to here 26, then 27, so that we will get B. So A plus 1. Now let us say B plus 27. How it will be processed? B plus 24 we will get Z, then 25, 26, 27. So how it can be taken? B plus 1. And we know that B plus 1, it should become C. Similarly, C plus 27, C plus 23 means we know it becomes Z, then 24, 25, 26, 27. It becomes B. So we know that it should be C plus 1, which gives us D. But from 27, how we can bring to 1? That is A plus 27 modulo division 26. A plus 27 modulo division 26. It becomes A plus 1. Similarly, in the case of B, B plus, to get this one, we have to say that 27 modulo division 26, it becomes B plus 1. And in the case of C, similarly, C plus 27 modulo division 26, C plus 1. So we are going to check if distance is greater than 26, we are going to convert the distance by saying that distance equal distance modulo division 26. So in our code, check whether distance is greater than 26. For that, I am writing an if condition. If distance greater than 26, we are going to cut short the distance by applying the modulo division. Distance modulo division equal 26. It is equivalent to distance equal distance modulo division 26. Now we are going to process each and every letter. Process every letter by adding with distance. For this, I am going to use a for loop. For every letter, let us say a variable ch in our message variable name my message. So my message. Now every letter may be a lowercase or uppercase. So first of all, let us verify whether it comes within the lowercase range. Check whether it is a lowercase letter. For that, I am going to put a condition. If the letter CH is greater than or equal to A, and this A should be given within single quote. So this CH, it can be A or B, C, any character, but it should be less than or equal to small letter Z. Now we can ensure that if it is from A to Z, then do the remaining process. Now we have to convert this CH into Unicode as I mentioned earlier. For that, we have to take ORD of CH, because every letter should be added with distance. So before converting that letter into Unicode. So here we'll get the Unicode plus distance, and it can be stored in a variable called data. Someday when we add this distance, it can cross the final letter Z. Let us see what we have to do in such case. So I am going to show my Excel sheet again. Let us say that we have a letter X. For X, Unicode is 120. And here take the distance as 3. So 120 plus 3, we know that it becomes 123. So 121, 122, but we should not take 123. What we have to do is we have to loop back to the beginning of the alphabet A. So it should become 97, and we have to say that 120 plus 3 is 97. But how do we change from 123 to 97? We have to subtract with 26. That is 123 minus 26 equal 97. Take another letter Y, and its Unicode is 121. So 121 plus 3 means 124. So plus 1, then 2, 3, 124. So we have to bring it 98 here. So from 124, how can we change this into 98? By subtracting with 26. Then for Z also we can check it. 122 plus 3, 125. So plus 3 means 1, 2, 3, 99. So from 125 we have to bring 99. It can be done by subtracting 26 from 125. So in our code, we have to check that if this data, that is after adding with distance, if the data is greater than 122, if the data is greater than 122, here we are getting 123 after adding. So after adding, if it goes more than 122, subtract with 26. We have to say that data minus equal 26. It means data equal data minus 26. Now this should be converted to character. For that we have the function char of data, and this should be appended with ciphertext. For that, ciphertext plus equal converted character. Now we are going to check whether the letter is an uppercase or not. Check whether it is an uppercase. For that I am going to use else if, that is here if. Here instead of small letter a we have to put capital letter. Here instead of small letter z we have to put capital letter z. So capital letter A less than or equal to CH, where CH less than or equal to capital Z. So CH lies in the range from A to Z. And here also we have to do the same process. Data equal the Unicode plus distance. So I'm just copying that, put it here. After adding, the data may cross the boundary. For lowercase, as it is shown here, the lower limit is 97, upper limit is 122. Here, capital A Unicode is 65, and for Z, which one is the upper limit? Its Unicode is 90. So here, after adding with the distance, we checked that if the data is greater than 122. For uppercase, after adding with the distance, we have to check whether the data is greater than 90. Then we need to loop back to A here. So check the condition. If data greater than 90, then the same process, because in the uppercase also we have only 26 letters. So same subtraction need to be done. Then after that, convert the data into character, and it can be appended to ciphertext. Someday the message may contain some special symbols or comma, hyphen, underscore. For that, we have to just include as it is. So I am going to put a final else ciphertext plus equal to ch. So if it neither belongs to lowercase nor uppercase, take the character and append to the ciphertext as it is. And now we can print the final processed data. Print encoded data is ciphertext. Let us check it whether it is working fine or not. So I am going to put apple apple, and I am going to put a distance value 3, and you can see that after adding a with 3, so B, C, D, and for P, Q, R, S, for L, M, N, O, E, F, G, H. Now let us decode also. So from BSSOH, we have to bring back apple, that is the original text. So next we are going to decode it. Here I used a variable called cipher text to store the encoded data. To decode, I am going to use a variable called my text. Now process the generated cipher text. So I am going to use a for loop for each letter in ciphertext. Again check that whether it is a lowercase or not. So the same step I am copying it here. For example, here the converted one is capital D, and for the next one it is a lowercase. So first we are going to decode for lowercase. If it is lowercase, what we have to do? So from D we have to get capital A. From small letter S, so in this case from small letter S we have to reduce to P. So from P we got S by adding 3. Now from S, if we want to get back the P, we have to subtract the distance 3 from S. Subtract distance from the letter CH. Now CH is a str data. So first of all we have to convert that CH into Unicode by using the ORD function, ORD of CH. Then from that Unicode subtract distance, and it can be stored in a variable called data. And here when we subtract, there are some challenges. Assume that the decoded letter is A. Now let us say that we want to subtract 1 from 97. 97 minus 1. It becomes 96. But 96 is not within this given range. So minus 1 means it should go to the end of the alphabet and it should point to 122. So 122 is the expected one. So from 96, how can we get 122? We have to add with 26. Let us say that we have 97 minus 2. 97 minus 2 means 95. So 97 2 times. Minus 1 means it should become 122. Minus 2 means, so one more time, 121. So with 95, when we add 26, we will get 120. So here, after subtracting distance from that Unicode, check if data is lesser than 97. So 97 is the Unicode for A. If it is lesser than 97, then add data with 26. Come out from the if condition and convert this Unicode which is available in data into character and this can be added to my text plus equal chr of data. Now we are going to check whether it is a uppercase. For that, here we have the condition else if whether it is in the range from capital A to capital Z. Just copy paste, and here also the same thing, subtract distance from the letter CH. So in the case of capital letter, we can check if data becomes lesser than 65, where 65 is the Unicode for capital A. Then we can say that add data with 26. Come out from the if condition and convert that Unicode result which is available in data to str. For that we have the function chr of data. So we'll get that particular character and that can be added to text. Sometimes there may be comma or some other special letter. So here also we dealt the same thing. If none of these cases, just put a final else, and here it is not ciphertext, we have to put my text. And now we can print the decoded message is my text. Now let us check the output. So I am going to put apple is good. Let us say that this is 28. So 28 is the distance, and you can see this is the encoded data. You can see the white space is added as it is by using this else condition, and when it is decoded also as per the else message, here the white space is added as it is, and you can check with the greater distance value. Let us say that another word with 500 distance, and you can see that is also working fine. Hope that all of you understood how the encoding and decoding are done here. Thank you for watching this video.